All right, we're going to start out with a quick review of exponential growth and how to get your money to behave exponentially, which is a great thing. Maybe at the end of this, you can take some money, put it in the stock market, and once it rebounds, you'll be all set. All right, let's take a small look at this little piece of an equation here. 1 plus 1 over n to the n. And it doesn't seem like that's got much to do with banking and money, but it actually has a lot to do with it. So in class, I would divide up all this work. I'll do one or two, and then you can pause it and do the rest. So the first thing we're going to do is plug in a 1. And if you go 1 plus 1 over 1 power 1, this would be 1 plus 1 is 2 to the 1, which is 2. Big deal. But what happens is you start to put larger numbers in there. Well, let's go right on here to our calculator, and we're going to go 1 plus 1 divided by 10, power 10. And you get 2.6. So it got a little bit bigger. Well, let's try a 20. Second enter. We'll plug in a 20 right here and a 20 right here. And you get 2.65. So it got just a little bit bigger. Well, the question I have for you is if you just keep plugging in bigger numbers here, does it just keep getting bigger and bigger and bigger and go on to infinity, or what does it get closer to? Well, let's just try, maybe I'll skip one or two, just let's try 1,000. I mean, let's just jump right to a larger number. So we'll hit the same thing here. We have 1,000, close it off with power 1,000. Take a look, and we got, well, just a little bit bigger, really not 2.72 is all the bigger it got. Maybe I thought it would actually get a lot bigger than that, because I mean, 1 being plugged gets 2. I'm only up to 2.72. Well, it appears this thing has a limit, a thing that it's approaching, but never actually nearing it, and it does. If you plugged in the largest number you can think of, or just kept plugging in larger and larger numbers, so much so that you were plugging in infinity, you'd get 1 plus 1 over infinity to the power of infinity. And if you could do that, I understand you can't, you would get the number e. Well, what do you mean the number e? Well, there's a guy named Leonhard Euler who played with this little fact right here, with this little thing, and just kept plugging numbers, bigger numbers into it, and he found that it got closer and closer to a certain number, which is about 2.72, a number that shows up in banking a lot, and we'll look at that right now, or in just a sec. So he named the number after himself. So if you come up with your own number, you get to name it after yourself too, which is kind of nice. On your calculator, the E button is the exact same as your division button. So if you hit second and divide and then enter, boom, that's what you get. You get 2.718. It looks like it repeats. It actually doesn't. It goes on and on forever, never repeats, sort of like pi. All right, so how does that come up? Well, first we have to review our compound interest formula. It goes like this. A equals P1 plus R over N to the NT. Sorry, my N is ugly. N to the NT. Notice this N and that N are the same. It's the same letter twice, and that's on purpose. All right, this is, if you go and bring your money to the bank, this is how they are going to compute it, or one way to compute it, I should say. A stands for amount, and the idea with that would be your final amount after you make an investment. P right here is a money word, which is principal, spelled the same way as principal mecus. That means what you start with. So when you take your big sum of money, you take it to the bank and bring it there, it's going to start out as a principal and it's going to end out as an amount, as a final amount. R up here, another money word, is the rate. The way that you can quickly find a rate is that you find the percent sign. T stands for time. We're always going to put that in years. And N is the hardest one to understand, and we'll talk about it in a sec, is the number of times interest is compounded. The number of times interest is compounded in 1 year. So we'll get into what exactly that means, but the number of times you put interest back into the account so that you can get interest on your interest. Well, all these make sense. The hardest one is N. There's going to be some vocabulary that just shows up casually in the problem. It's not going to say, oh, by the way, your N value is 4. There's going to be a word that just comes up, and you have to be able to recognize it in order to know what number goes for N. So if something happens once per year, we say it happens annually. So if you see the word annually, that means that your end value is 1. Twice per year, you might think, oh, biannually. Well, biannually actually means every 2 years or every other year. It would be semi-annually, it means twice per year. If something happens 4 times a year, it happens quarterly. If something happens 12 times per year, it happens monthly. 52 times per year would be weekly, not strongly. And 365 would be daily. And if it happens an infinite number of times, you never stop putting your money back into your account so you get interest on your interest. We call this continuously. Continuous interest. So this idea here is going to be tied to that right there. All right, let's try an example or two. We'll get to this formula up here, but first let's just get through this. Sharon wants to have money to give away. Okay, you got my pun there, Sharon? Forget it. Have money to give away. So she invests $4,000 in an account with an interest rate of 6.2%. If she leaves the interest in the account, how much will she have after 4 years if interest is compounded monthly? So let's give that a try. We'll start out with our first amount, our principal. Our principal is $4,000. We're going to have 1 plus. If I'm going back to the formula over here, it's going to have an R on top and an N on bottom. Your R, be careful, it has to be a decimal. So 0.062. 0.062. You might think, but it's growing. It's 1.062. It's not. The 1 is actually already in the equation for you. You don't need to put the 1 there. If we compound monthly, we're going to divide by 12. And just so you know, in that formula, the N shows up twice. You divide by N, and then you also power N. So 12 here, and then you have 12 here as well. And it says for 4 years. After that, it's all punching in numbers. If you have a newer calculator, your calculator is really good at organizing stuff like this. We can go 4,000, 1 plus 0.062 divided by 12 power. 12 times 4. If you have an older calculator, you're going to have to use some parentheses to make sure the 12 and the 4 go together. So my calculator puts both of them up as an exponent. If you have maybe the older gray ones, you got to go power and then put the 12 and the 4 together, multiplied in parentheses so they go together. And you get it? You get $5,122.57. All right, well, not that it's going to make a big difference, but how about if she compounds daily? So everything else is the same, but we're going to compound daily. So I'll take $4,000. We'll go 1 plus 0.062. This time, this 12 is not going to be a 12 anymore. Now we're going to put a 365 there and also go power 365 times 4. And same thing, I can hit second enter on my calculator. Get this. 360, insert a 5, power 365 times 4 up there. So everything else stays the same, and you get just a little bit more. I mean, not a lot more. It's like $3 more. We have $5,125.73. But, I mean, I'll take $3 because if you're looking at the money that I contributed, the same. The interest rate, the same. The time, everything was exactly the same. The only thing that was different was the number of times we compounded, so we got an extra $3. Now, add more than 4 years and more than $4,000, and this number of times you compound becomes a very big deal. It starts to work in your interest quite a bit. All right, the last one is, how about if we did this continuously? So I should write that answer down. I should 5125.73. All right, let's see if we can get even just a little bit more out of our investment. We're going to do things continuously. Well, here's what you would do. You go A equals P, 1 plus R over, but if it's continuously, that means the number of times you compound is infinity to power infinity times T. Well, this number right here we talked about on the front side is got, this number is E with an R in it. This is E to the R. Okay? So if we're trying to find our formula, it's actually exactly the same as before. We have A equals P. This little piece of the formula is going to be e to the r times t, so we call it the PERT formula. PERT plus, great here, no fuss. So we have your principal times e, which is on your calculator, to the power of rt. Principal is 4,000. You're going to multiply times e to the power of your rate, which is 0.062 times time, which is going to be 4. So on your calculator here, 4,000. E remembers your division button. So second and divide to the power of 0.062 times 4. And we got, only 10 cents more or 11 cents more. But like we said, it's all about taking what you have and maximizing it. Get the absolute most you can out of it. So like I said, this investment, if you put it over more money and more time, you might see a bigger difference between that and your first one. All right, last topic for today is what does it mean for interest to compound? Well, the best explanation I've ever heard comes from Dave Ramsey himself. Here's what he says. Let's take $100 and put it in the bank. And let's say that I give you 10% of your money. If I give you 10% of 100, hopefully we all agree that 10% of that money would be adding $10 for a total of $110. So we can all agree that 10% is $10. Okay, we have to establish that 10% is $10. Well, you are a smart and diligent person, so you take your $110, you leave it in the bank, and now you're going to give yourself, or the bank is going to give you 10%. So 10% of your money, we said, well, 10% of 110 is now not $10, it's $11. So hold on one sec. Why was 10% $10 the first time around, and now 10% is $11 the second time around? Well, the reason is because you got interest on your money, but you also got interest on your interest. And that's what it means for interest to compound. So here, 10% used to be 10. Now 10% is 11, so I have $121. Let's be studious again, put it back in the bank. And now we're going to give ourselves 10%. That's $12.10. So you can see 10%, that amount that you're giving yourself starts to grow. Okay, so what does it mean for interest to compound? You get interest on the interest. That brings us to the idea of something called a yield. Well, if we're looking at a rate, for this example right here, the rate is 10%. The bank gives you 10%. But the problem, what I want to know is what's the yield? Because if I'm looking at this, compared to my original amount of money, first 10% was 10, then 10% was 11, then 10% was 12.10. And I want, well, what's the best that I can do in a given year? In 1 year, I obviously can get better than 10%. If you talk about compounded interest and all that. So the rate, that's simple. That's just the percent. So in this example right here, my rate is just 10%. But the yield is the percent when you include compounding. So the way you do it is use the same formula. You go A equals P, 1 plus R over N to the NT. And then you get rid of the parts of the formula you don't need. First of all, your rate and your yield, it is completely irrelevant to the amount of money that you start with. Whether you have $1 or whether you have $1 million, your rate, your 10% is going to be the same. So what we're going to do for yield is we're going to get rid of the A and the P. Those don't matter, the amount of money. The other thing is it's an annual yield. How good can you do in 1 year? So we're going to put in a 1 for T. N times 1 is just N, so we don't need it. So here's how you figure out your yield. This is as good as you can do in 1 year. So my annual yield for this would be 1 plus, my rate is 0.1, and I guess we're going to have N power N, and we'll have to plug in the number of times we compound to figure it out. Let's look at example 2, and I'll try it. Find the rate. Easy, 8%. Now find the yield. How good can you do on that investment if you take the compounding into account? Well, here's what we're going to do. We're going to use this part of the formula. So we're going to have 1 plus my rate, which is 0.08, and it says that we're going to compound weekly. So the bank is going to give you 12%, but if you put interest back into the account 12 times throughout the year and start to get interest on your interest, how good can you actually do? Well, let's check it out. we're going to go 1 plus 0.08 divided by 12, 12, power 12, and get that for an example. Now you have to be able to interpret that result. This is a growth factor. We have 1.082999, meaning I'm going to take your money and multiply by this number. But the question is, what am I growing by? Well, when you're growing by, this is 108.3%, meaning you're growing by this number right here. So slide the decimal. This is a 8.299% growth. Okay? What that means is the bank gave you 8%, but when you put interest on your interest, it grows better. You can actually get up to 8.299%. All right, try the last example, and we'll call it good. All right, find the rate. That's 6%. That's easy. The yield for something that compounds continuously. Same idea. We have A equals P, E to the RT. Get rid of the parts of the formula that don't matter. A and P, you don't matter, because it doesn't matter if we have $1, if we have $1 million, the growth rate is the same. It's an annual yield, so we're going to plug 1 for T, so you're going to be gone. So it's really just E to the R. So in this case, we're going to have E to the power of 0.06, and then we have to interpret that result. E power 0.06, and we get this number right here. Remember, this is a growth factor. This is how our money grows. It's not that we're getting 1.6% or 1.06%. We're multiplying our money by that, so it's a 6.18% growth. So the best you can do on that account is 6.18% per year.